The name of this talk is Planning Ahead, Building Transactions with Complex Spending Conditions in BDK. I go by Valued Mammal on GitHub, and I'm a contributor to BDK and currently being funded by BDK Foundation. So before we get to the planning ahead stuff, this is like a brief refresher on spending policies. And so a policy, it basically describes one or more spending conditions. And policies can be composed of a number of individual sub-policies. So in this simple example, the way you would read this is both A and B must sign, or C can sign after 144 blocks have passed since the UTXO was created, or once the coin has reached an age of 144 blocks. So the policy language is meant to be a high level, it has a simple syntax. You can see the white space is more sort of for readability, but it's a simple syntax that's meant to be human readable. And it's a language in the sense that it compiles down to Miniscript. And the reason why should you care about policies and Miniscript is sort of to motivate it is, we want to move beyond just a simple single sig wallet. So describing more complex spending policies is what enables us to have more complex, allows us to encode things like contracts and contingency plans at the level of Bitcoin script. I think that is pretty clear. So you could make like vault type structure. So then in the second box, you see a Miniscript descriptor that's a pay to witness script hash descriptor type. And in the real world, the A, B, and C would be substituted for actual keys, right? Pub keys, you could use a private key, or you could even use like an XPub with a wildcard. Okay, so then quickly, I wanted to discuss the current state of the API in BDK is what is called this policy path API. So this is a function in Rust on the TX builder type. It's called policy path, and it has two parameters: the policy path map and the keychain specifier. So if we just read the docs, it says this method accepts a map where the key is the policy node ID and the value is a list of indexes of the items intended to be satisfied. And then it gives an example of a descriptor. You see in the code block witness script hash, and we see a thresh followed by a 2, and then like a whole bunch of gibberish. So we know right away somewhere in the descriptor there's two conditions that out of the total has a threshold of 2 that we need to meet. And then it sort of breaks down each one into 3 individual conditions. So there's a key A, and then the second one is key B plus an older fragment, and the third one, key C plus an after fragment. And then sort of moving on, at the bottom, when the policy is represented as a tree, every node is assigned a unique identifier that can be used in the policy path to specify which of the node's children the user intends to satisfy, blah, blah, blah. So that's what an entry in the map would look like. You have a policy node ID, which is a string of characters, and then the value is this vector of indexes. So it's a little sort of arcane. And so the key, again, to reiterate, is a policy node ID, and the value is a list of children that should be used. It says in no particular order, but so it could be 0, 1 or 1, 0, but I guess maybe the docs aren't exactly clear, because I'm assuming the order does matter in the sense that we're picking the first and second in the numbered list of these conditions. So the goal of my talk is to try and convince you that try to improve on this API to be a little easier to work with, right? Because a failure to do any of the above mentioned steps will definitely result in an error, and that looks something like this. It says the spending policy is required, and then it lists the keychain. But to sort of step back, it's important to understand why this error occurs, right? Because as a developer, this would be an annoying thing to come across. But what it's saying is you have to, the spending path is ambiguous, so you have to tell BDK which path you're going to take, because that influences the information that we put in the PSPT. But so like if you had a single signature wallet, there's only one path, so you normally don't have to worry about this. So, but the minute you start dealing with more complex descriptors, you're suddenly forced to confront that this policy path notion of, and there in the previous slide, the policy path is sort of this encoding. But that's basically why, like, to give an example of the information in a PSPT would be like, if you're assigning with key A or key B, well, the key origin or the derivation path might be different. So, right, I hope that's clear. And then here's just a visual representation of the policy object, and the point is not necessarily to understand every line, but just to see, get a visual for it, and also since it kind of runs off the page. But the thing, and again, that's a refresher of the example descriptor from the documentation. And so the thing to note is that what I want to convey is it's kind of a painful UX, because so here's just the conditions listed in this sort of nested structure. And one of the things that's not very pleasant about it is this idea of the policy node ID, which is, there's not really a rhyme or reason to where this ID comes from. And if we're getting technical, it's actually like a checksum of the JSON serialized policy node item. But it turns out that this node ID could actually change depending on which keys happen to be available in the wallet. Like if you had a watch-only version of wallet A, where there's no signing keys present, the node ID could change, and so it becomes hard to track down it's hard to track down, right? It's not very intuitive. And then this is a continuation of the last slide, which is this same policy object. But here, sort of at a glance, you can kind of get a sense for, there's a M of n, so that's the 2 of 3 thresh, and then it lists the conditions, and if you take path 0, 1, there's this extra condition that has a CSV, path 0, 2, so there's three ways, and we need to pick 2 of them. So that's sort of the intuition. But so now I want to introduce a new idea called the plan. And the plan is, it's conceptually, when you hear policy versus plan, conceptually we're talking about the same thing. It's just the spending plan. It just has a new name because of the new and improved code. So what is it? It's just reading from the docs. A plan represents a particular spending path on a descriptor, contains the witness template and the time locks needed for satisfying the plan. Calling plan on a Miniscript descriptor will return the structure containing the cheapest spending path possible, considering the assets given. And so why is this interesting? What the plan does is finds the minimum satisfaction out of a set of satisfiable conditions. This has a few benefits. Preserving privacy by not revealing every possible condition, and saving on-chain fees. I guess those two are kind of one and the same, because revealing less information should equate to smaller on-chain footprint. So how do we get a plan? The docs tell us by calling plan on a descriptor, considering the assets given. So at this point, you're probably thinking, but wait, what are assets? So to take a slight detour and introduce this concept of assets, sort of my informal working definition is the assets consist of the information that we bring to the transaction, indicating the conditions we intend to satisfy. So you can see this is analogous to the policy path idea, but in a lot of ways, this is a lot more explicit. If you remember back to the policy, it was sort of cryptic by its own nature, the way it encoded the spending path. But with the assets, it's really explicit, because you're gonna, if there's 3 different keys that are available, you really just say, I intend to sign with key A, or key B, or key C. Or if there's a time lock, you say this transaction needs to meet this absolute time lock, and you just provide the time lock. So like the most simple example I can think of is a single sig transaction has a single satisfiable condition, that being the signature. Therefore, the asset that we bring is the key with which we're able to produce the signature. Note that the assets consist entirely of public information, so we're not revealing secrets or sensitive data of any kind. And what's interesting is a key in this context is kind of an abstract identifier for the key that you care about, that can be denoted by the combination of a master fingerprint and derivation path, or the key source, together or along with the context in which it can sign. Historically has been EC, DSA, or Schnorr. And there's other kinds of assets in addition to keys, like hash locks and time locks. So at a high level, the UX would look like what you see here: a descriptor, a public descriptor at a derivation index gives you what we call a definite descriptor, which is something that can derive a specific pub key. The definite descriptor plus the assets gives you a plan. And then the plan plus the UTXO you want to spend is enough to create an input. And this is an input that now knows its satisfaction weight, or the cost or the weight of the input once it finally is satisfied. So when you have inputs and outputs plus a target fee rate, this is what allows you to do coin selection and ultimately populate a PSBT. And then the PSBT plus the eventual satisfaction, like, for example, a cryptographic signature, is what gets you to the final transaction. So sort of the intuition you should have in mind is as I increase the fee rate, I might need to pull in more inputs from the wallet. But of course, every input I add is adding weight to the transaction. And so it's a sort of chicken and egg, because before you have a signature or a witness, you need some way to estimate the satisfaction weight. So that's what the plan tells us. So you have a complex spending path that it'll have a larger satisfaction. Is that sort of clear? Okay, so moving ahead, putting together sort of the core concepts, like the takeaways. The plan gives us the minimum satisfaction. And without this, you'd be forced to rely on something like the max weight to satisfy, which could become wasteful if there's a single uncommon path that requires a large satisfaction. The satisfaction weight enables us to do more efficient coin selection. The plan also lets us update a PSBT with just the pertinent information without revealing too much. And of course, this is a prerequisite to signing. And then the finalizer is a new concept that I didn't touch on, but the finalizer uses the plans to construct the final script SIG or witness. And of course, this is a prerequisite to extracting the final TX. So the new APIs that I'm looking forward to in BDK is analogous to the old TX builder, but what we're calling PSBT parameters. So you can add assets if you need to add additional assets that the wallet doesn't already know about. And then call create PSBT on the wallet, passing in the params, and use the finalizer to finalize the PSBT. I guess a disclaimer is that this work is actually just a pull request right now, so you can't actually, it's not live, but I would encourage people to review the code. Okay, so I wanted to give an example of an an inheritance plan. So I'll go over this quickly. Say we have a taproot descriptor, and to sort of paint a picture, a scenario, is you can see two script paths. There's the multi-sig with A and B on the left, and then the other script path is key C and an older fragment. So imagine you're key A, you and a cosigner have a 2-2 agreement, and the two of you can make transactions all day long together. And then C here would be your heir, and key C, like your spouse or loved one. Key C can sign on their own without a cosigner, with the additional stipulation that the coin has to have aged 52,560 blocks, which is like a year worth of blocks. And then the X represents the internal key here. This could be some other cold storage key, or could even be like an aggregate. It could even be like an aggregate pub key from some off-chain multi-signature scheme, where like you, your heir, and a lawyer maybe come together if the three of you agree on spending. Just an example. So what are all the possible assets that are available? It's each of the keys. So X is an internal key, and then each of A, B, and C, and then older we consider that an asset because it's a time lock. So then using that, I want to do some concept check questions. And the question is, for each set of assets that I'm about to show on screen, what is the chosen spend path? That is, what does the plan tell us about the spending path that we're taking? And what's the resulting tap script? And then I just put on the slide some links, like a link to the Miniscript stuff, and which eventually became BIP 379. And there's also a similar example to this in the Rust Miniscript library. So that's where you would go to find all the information you need to answer this sort of question. So the first question is, if say my assets are keys A and B, well, this should be pretty straightforward. I'm taking the first script path, the multi-A, and that's what the script would look like. So when you see multi-A, you should think check sig add, which I guess is like the taproot way of writing a multi-sig. So what if I just provide key A? This is my only asset. Well, that's not going to work. The assets are insufficient. So why are the assets insufficient? because none of the possible spending paths can be completely satisfied by just a signature from A. So now what if my assets are C plus the older fragment? Hopefully we're starting to spot a pattern. This would be the second script path. Right? So hopefully that's clear. Yeah. So when there's the script, you have check the signature for C, and then op CSV with the value 52,560 in hex. Then, as a bonus question, say we just add all of the assets indiscriminately, just out of laziness. You know, I'm thinking, if I just add all the assets, what could go wrong? I can just decide later what I want to sign with, or what satisfaction to bring. What do you guys think? What's the spending path? It might not be obvious, but if you think about it, it's the key spend. It's just the key spend, right? Because if I have X, why do I care about the other? Why do I care about the other assets? Because normally we think of the key spend as sort of being the path of least resistance. So recall that the plan is meant to give us to find the minimum satisfaction. And you sort of have an intuition for this just by looking at the script, because the key spend will appear as just a single signature on chain, so the script itself is smaller. It's sort of an interesting consequence of the plan, but something to think in mind, or to keep in mind. And so hopefully you all have a better idea of how to build transactions in BDK in this sort of new paradigm, and that's all I have.
Do we have any questions? We have a couple minutes.
Is this supposed to be a replacement for the TX builder or an addition?
Okay, good question. This work coincides with a simultaneous replacement of the TX builder. So yes, and the reason for that is TX builder is more or less functionally deprecated, meaning we're not really spending much more time working on it. Because of all the new things we want to implement, it would be cleaner to introduce it as a separate structure.
So it will be compatible with BDK TX?
Yeah.
Okay, thanks.
All right, thank you.
Thanks.